Let's look at exponential equations that can be solved using the substitution method. Here's the first problem. To solve this problem, we rewrite the equation so that it looks like a quadratic. So we apply the laws of indices to rewrite 3 raised to the power of 2x as 3 to the power of x all squared. Now substitute a new variable for the exponential term. The exponential term is 3 to the power of x. So we substitute y for 3 to the power of x, replacing 3 to the power of x with y everywhere. Hence we end up with the quadratic equation y squared minus 5y plus 6 equals 0. To solve this quadratic equation, we can use the quadratic formula, or the factoring method. If we factorize, we end up with y minus 2 into y minus 3. To solve for y, we equate each factor to 0. So we put y minus 2 equals 0, and y minus 3 equals 0. Therefore, y equals 2, or y equals 3. Now recall that y is equal to 3 to the power of x. So we replace y with 3 to the power of x in both equations. Let's solve each equation separately. For the equation 3 to the power of x equals 2, we take the natural logarithm of both sides. The laws of logarithms allow us to put the exponent at the front to get x log 3 equals log 2. To solve for x, we divide both sides by log 3 to get x equals 0.631. For the equation 3 to the power of x equals 3, we can also solve by taking the natural logarithm of both sides. However, notice that both sides have the same base 3, so we can just equate the exponents. The value 3 is the same as 3 to the power of 1, therefore x equals 1. So our final two solutions are x equals 1 and x equals 0.631. Let's do another problem. Notice that this equation has a negative exponent. The first thing we need to do is to get rid of the negative power. We can do this by multiplying each term on both sides of the equation by e to the power of x. On the left, e to the power of x times itself is e to the power of x all squared. On the right, e to the power of x times 4 is 4e to the power of x, and e to the power of x times e to the power of negative x is e to the power of 0, since the law of indices states that we add the powers since the bases are the same e. Now substitute e to the power of x for another variable. Let's make e to the power of x be equal to y. This means we can replace e to the power of x with y everywhere in the equation. So we end up with 3y squared on the left and 4y plus 4 on the right, since e to the 0 is equal to 1. This is a quadratic equation, so we need to group the 4y plus 4 on the left to get negative 4y minus 4. To solve this quadratic equation, we can use the quadratic formula, or we can factorize. Factorizing the terms on the left-hand side gives us 3y plus 2 into y minus 2. To solve, we equate each factor to 0. So we put 3y plus 2 equals 0 and y minus 2 equals 0 and solve separately. For the equation 3y plus 2 equals 0, we subtract 2 from both sides and divide both sides by 3 to get y equals minus 2/3. And for the equation y minus 2 equals 0, the solution is y equals 2. Now recall that e to the power of x equals y, so we can replace y with e to the power of x. Hence we get e to the power of x equals negative 2/3, and e to the power of x equals 2 for the second equation. To solve the first equation, we can take natural logs of both sides. Notice right-hand side has the logarithm of a negative number, which gives error since it's not possible, so it has no solution. To solve e to the power of x equals 2, We take the natural log of both sides. Recall that the law of logarithms allows us to bring the exponent to the front. So we get x log e equals log 2. Now the value of ln e is 1, so our only solution is x equals ln 2. Thanks for watching. Remember to like, share, and subscribe. See you soon.